Welcome to chapter 5. So, under this topic, we are going to learn the differentiation, or in other words, we call that a derivative. Okay, so this word derivative is actually the same meaning as differentiation. So, after this chapter, you should know how to perform the basic differentiation rules. Right, so under the basic differentiation rule, there are two differentiation rule. They are called products rule and the quotient rule. We need to know how to use these two rules to find the differentiation of function, right? And also we need to know how to use the change rule to differentiate the function. Okay, and lastly, we want to learn how to find the slope of the graph. Okay. Now, for differentiation, the exponential rules is very important. So make sure you already master these exponential rules, right? We need to use all these rules to uh, help us to do the differentiation, right? So in case you are not very familiar, right, please visit chapter 1, our first lecture, recorded lecture, right? Chapter 1. So about the exponential law. Okay, so the exponential law, the recorded lecture will actually explain all this. Okay, so now before we start with the differentiation rules, so uh, we want to know what is differentiation. Now the differentiation, all right, the symbol is dy dx. Okay, what does that mean? It means that the difference of y divided by the difference of x. Okay, now do you remember we learned this definition before? The difference of y divided by the difference of x. Okay, so when we learn this definition, this is under the slope, right? Right, so for the slope, we take y2 minus y1 over x2 minus x1, and this is the difference of y, and this is the difference of x. So when we take the difference of y divided by the difference of x, this is the slope. Okay, now the dy dx is actually the same meaning, right? It's actually the slope, right? Having the same meaning, it's a slope. All right, so now when we have a straight line, for example, y equals to 3x plus 5, right? It is very easy for us to find the slope. Now, however, when we have a more higher function, for example, y equals to uh, 3x to the power of 5 minus 3x squared minus 5. Right, now it is not possible to find the slope using 2 points. All right, just as what we did for the straight line, it's not possible. So how do we find the slope of the graph? So we are using this technique, right, the differentiation concept. So to find the slope, right, for this type of higher function, higher degree function, we need to use the differentiation to help us to find the slope, right? So that's why we are learning the differentiation technique here. Okay, let's start with the first differentiation rule. Right, now if we differentiate a constant, we always get 0. All right, so now for example, fx is 5. All right, so this is actually equals to y equals to 5. Right, so when we differentiate, we put f prime x, So f prime x is 0, so we differentiate. All right, so we get 0. Okay, now how to explain this one? This is something that we need to remember. So when we differentiate a constant, right, any number without x, the dy dx is 0. Now, how to understand this? Okay, first we will have, now for example, for this equation, y equals to 5, it is a horizontal line, right? So when we sketch a graph, it's a horizontal line. Now, what is the slope here? The slope is 0, right? So for any horizontal line, y equals to 5, y equals to 7, okay? Or y equals to negative 2, right? Any horizontal line, the slope is always 0. Therefore, the dy dx is 0, right? Now, the second rule says that when we differentiate, all right, the x to the power of something, right, x to the power of n, okay, so when we differentiate, we bring the n down, all right, we bring the power down to multiply, and the power reduced by 1. Okay, so for example here, when we differentiate x to the power of 7, we bring the 7 down, this 7 we bring down. All right, so and 7 minus 1, we have power 6. Okay, now for this, then we lead to another rule, all right, if the y is the x, all right, so when we differentiate, we will get 1, right? The reason is, right, for the y equals to x, the power is 1. So when we differentiate, we bring the 1 down, all right, so we have 1 minus 1, so we have 1 to the power of x, 1 times x to the power of 0, all right, and x to the power of 0 is 1, therefore we get 1, all right, so we do not have to show this every time when we differentiate, right? So we know that when we differentiate y equals to x, when we differentiate x, we always get 1. Okay, when we differentiate the x, you just put 1. All right, so these two, they come together, right? We call this power rule. Okay, all right, now the third rule that we need to know is when we have a number in front of x, right? We have a constant in front of x. When we differentiate, right, we differentiate the x only, all right, so the constant we just copy and we multiply later. All right, let's take a look on this example. All right, so 3x to the power of 8. So when we differentiate, all right, remember to put the f prime. So we bring the 8 down. Okay, so we have 8 minus 1, 7. So 8 bring down, yeah, 8 minus 1, we have 7. Later, right, we take 3 times 8 is 24. 3, 8, 24, x to the power of 7. All right, so, okay, now the fx and f prime x is the differentiation of fx. All right, so fx and the y, all right, they are actually the same thing but different expressions. All right, fx we express the function, we express the process of the function, but y and 3x 8, this one, we actually tell the relation between the x and y, right? The two output and the input here. Okay, so right, if the question gives you fx, when you differentiate, you put f prime x. When the question gives you y, when you differentiate, you put dy dx. Right, so dy dx, so same, it will be 24x to the power of 7. Okay, rule number 4. Now, when we differentiate two functions of x, right, two functions of x, and they are plus or minus, so what do? We differentiate them separately. Right, for example, fx equals to 7 plus x to the power of 12. So when we differentiate this, first we differentiate the 7, so we get 0. After that, we differentiate x to the power of 12. So when we differentiate this one, all right, we bring the 12 down here, and 12 minus 1, we get 11. All right, so We have 12x to the power of 11 plus 0. So we have 12x to the power of 11. Right? So these are the four basic differentiation rules that we need to remember.